lesson 12, what we're going to do is we're going to talk about logarithmic function manipulations and basically talk about how we can use properties of exponents, which is basically properties of logarithms, to kind of change the way we look at it or format different things. This is just a real quick reminder of what those manipulations mean. These should hopefully make a lot of sense because just let's think of the product property. If I have like 3 to the 4th times 3 to the 5th, remember what you do. You keep the same base, and when you do those exponents, you add. So what happens, or vice versa, I can take the 9 and split it up here. What do we do with quotients? Well, think about quotients. If I have x to the 8th over x to the 6th, what do we do with those two numbers? We subtract, right? So when we see division, we subtract. When we see multiplication, we add. This one, remember, we talked about this a little bit a couple days ago. Exponent on the outside becomes a multiplier, okay? So that multiplies how many exponents we have. So let's do some manipulation of this to kind of see what happens. We're going to expand in number 1 and condense in number 2. So in number 1, this is all multiplication here, so that's what I'm going to start with. I want to separate the 8, the x, and the y to the 4th all with addition. Now, a couple other things that I'm going to do is this 4 is an exponent. I'm going to move it out in front. So it's going to be 4 log of y. This log of x is going to stay the same. I'm also going to try to get that into the lowest base with the number 8. So this is going to become log base 2 of 3 because those mean the same thing. And as you can probably guess, I'm going to take that exponent and swing it to the front. So 3 log of 2 plus log of x plus 4 log of y is the expanded form of that. I'm going to have you do b in just a second, so let's hop down to example 2a. We have natural log. What's going to happen is I'm going to merge those together. Well, actually, nope, I want to back up a little bit. I want to take care of this 2 out in front. Remember that 2 can go the other way and be written as an exponent. So ln of x to the 5th minus ln, and it's important I do the quantity of xy to the 2nd. Now that I don't have any coefficients, I'm going to merge them together through division. So x to the 5th on the top. And then what's going to happen is I'll distribute right away. So this is going to be x squared y squared. Now to wrap this up, I can see those x's right there. I can condense that anymore and clean it up. X to the 5th over x squared. That's going to become x to the 3rd over y squared. All right, what I want you to do real quick is pause the video and do example B by yourself in both 1 and 2, and then unpause it. All right, so you can see those answers right there. We separate the division by subtraction. You can see that. You can see how we took the exponent out in front. I'm sorry, the exponent moved it out in front. Notice I kept the x squared plus 5. That's because it's a quantity, and I can't break that apart, just like I want to be able to break that apart with exponents. When we move down here, you can see how I moved the 3 as an exponent, right? That quantity, distributing it within that parentheses. Same thing on the right, distributing and moving that exponent up and then distributing. And now once I get it kind of cleaned up in both spots, what I can do is that I can merge them together by multiplication, adding those exponents for that final part. One thing I did not make clear before is that we have to make sure that they are the same base. So if you had something like log base 5 of 6, and then you had something like log base 5 of, log base, let's make that an 8, log base 8 of 2. If these have different bases, you can't merge those together. So that base has to be exactly the same before you do anything like that. There's this change of base formula. Before, their calculator powers really weren't where they needed to be to give us what we needed to punch those in. So what would happen was that there would be a table in the back of a textbook that would have a bunch of numbers for base 10, bunch of numbers for base E, and then you could kind of look it up and do this property. And what it's basically saying is that you can take a logarithm that has a different base, right, besides E or 10, and you can make it a division problem as long as then you use the same base. So what happens is a lot of times when you have something like this, you're going to use that common log base 10, okay, that common log with base 10, and you just put this in the numerator, that in the denominator, and then divide. Same thing with ln. Makes it the same, bases are the same, so you can divide it. We're just going to do one of them just to show you what you would do. You would do log base 13 over log base 3. You'd put that in your calculator. Or you could do ln of 13 and then divide it by ln of 3 because those are the same bases. Plug it in your calculator. So pause it, put in your calculator. You get 2.335. The last problem we're going to do is we're going to take a look at logarithms and logarithmic properties and show how, something like this, which would be a horizontal stretch, right, because it's affecting the x, can also be a vertical translation just by kind of manipulating the properties. So if we take the original logarithm, log base 2 of 4x, and we separate it, we make it log base 2 of 4 plus log base 2 of x. And then I rearrange that 4 to be 2 squared. Now swing the 2 to the outside. It's 2 log base 2 of 2. Well, what happens to log base 2 of 2? It cancels out. So now what we're left with is g of x equals log base 2 of x plus 2. See how that vertical shift, that add 2 at the end, is going to translate to that. It means the same thing. So we've already kind of know this. We've seen what log base 2 of x looks like, right? Okay. Which is f of x, or definition of f of x. That's it here. There's my asymptote. It's going to cut to half, 2 to 1, 4 to 2, 8 to 3, and it swoops like this. Okay, so again, 2 to the third, that's where I get that right there. So we have this, and what this is right here, it's a vertical translation, meaning we shift all these points up 2. Well, that doesn't shift the asymptote, right, because it's already vertical. But I'm going to move this up 2, this up 2, 2. Oops, I was a little bit off at that point. Sorry, this should have been here. Okay. So again, fixing that real quick. Move up 2, that goes there. And again, you can see kind of that shift happening. Okay, goes up. The other thing we talked about was that this is a horizontal stretch. And it's actually by 1/4. So think of your x values right here. So if this value right here is 1, 0. Actually, I want to use a different example because this would become 1/4, 0, which we don't quite see, but it is there. Let's use this one. This is 8, 3. If I times this by 1/4, that's 2, 3. Do we see that point? Yep, there it is. So again, the horizontal stretch is also, or can also be, a vertical translation. So as x increases by 1 unit, the y values are shifted up 2 units. So a vertical translation of plus 2. So if we have x comma y, we're adding to the y. So it would become x, y plus 2. And again, we kind of saw that that's the same as 1/4 x comma y.